Hi guys. In this video I thought I would show you how to program something. So we're going to program a maze in JavaScript. JavaScript is not a language I'm really comfortable with, so it's been fun to program it myself, and I'm going to show you what I came up with here. So I have one HTML file and one JavaScript file. I'm going to actually type out everything so you can see what I'm doing. So the first thing I'm going to do is the HTML file. So we're going to do doctype HTML. And then HTML, close that, and wow, I'm realizing that this editor doesn't do anything for me, so I'm really going to type out everything. Let's see, let's go ahead and include a meta char set equals UTF-8. And for the title, let's make this solve a maze. That sounds pretty good and descriptive, and I realize I have one of my slashes going the wrong way. And then for our body, pretty much we just want a canvas. So canvas is just an area you can draw in, and it's built into HTML. So canvas, we'll just put ID equals, how about my canvas, width shall equal 1200, height is going to equal 800. Okay, so I've created a JavaScript file already, this maze.js. So in case you don't know, I've got an HTML file, and then this .js is a JavaScript file. So we're going to run that script. So script, the source src is equal to maze.js. Okay, and that's all we're going to do inside of our maze. And so that should, if we open up this HTML file, open up in your browser. And this is what it does. It's just a blank window right now, and it has a canvas on it that we're going to be able to draw on. So to draw anything, we need to go into our JavaScript file. First things first, we're going to create variables. We want a variable canvas, which will be the canvas we just created, and the variable ctx, which is the context, and that's what's going to allow us to draw it into our canvas. Let's see, and I'm going to create a function to initialize everything. So function init canvas is going to equal document.getElement by ID canvas. Oh, I'm sorry, my canvas. So of course that's going to go to our HTML document and look for the thing that has ID my canvas, and it's going to store that in this variable in our JavaScript. So our JavaScript is able to refer to the HTML document. And let's see the context. So ctx is going to equal canvas.getContext2D. Okay, because we're drawing a flat maze, so we just need 2D graphics here. And I'm going to run the init function. Okay, so right now I've stored a canvas in a context. Let's go ahead and draw something on the canvas so that we can see what's going on here. So I'm going to create another function, and it's going to be called draw. And what I'm going to do is ctx.fillStyle. This will set, we're going to use this to set a color, and we're going to use hexadecimal colors of it here. So I'm going to go all the way up to F and basically just max out the red. So we've got red, red all the way. And then what I'm going to do is ctx.beginPath ctx.rect. Let's just say 10, 10, 50, 50. And then ctx.closePath and ctx.fill. Okay, so what we're going to do is fill in a rectangle from the coordinates x and y, coordinates 10, 10 as the top left corner, to the xy coordinates 50, 50 as the bottom right corner. Okay, so let's see how that looks. We run this. And by run, of course, I just mean open up our HTML, and nothing appears. Oh, that's because I didn't run the draw function. So let's go ahead and run. Let's run it within our init. So inside of init, I'm going to run draw. All right, let's see if I refresh that. Now we have a red square. The x coordinates start, well, both coordinates start in the top left corner. So x goes over 10, and then the y is going a positive 10. And remember, unlike algebra class, y being positive means go down. So we actually went down 10. And then x goes over 50 and down 50 for y being plus 50. Okay, so we drew a red square. It's quite a bit of code just to draw one square. So we begin path, set a rectangle, close the path, and then fill it up with a particular color. So I think what would be best to do is make a function just for the rectangle. So I'm going to call it a rect. And we're going to take in some coordinates, x, y, width, and height, see? And what we're going to do is fill the path. So we're going to go to this x coordinate, this y coordinate, and then we're going to have a width and a height. So excuse me, I think I said 50, 50 was the bottom right corner. Looks like we could set it to be that way if we wanted to, but automatically it's going to actually be the width and the height of the rectangle. So let's test that out. Okay, so rect, we'll go 10, 10, 10, 10, maybe. So let's see what happens. I guess I closed it. Yep, okay, we get a 10 by 10 square. So that's actually the width and the height. And the second, the second set of coordinates is width and height. We're going to want to actually draw this over and over again. So we're going to return set interval, draw 10. And what this does is it runs a timer, and I've actually honestly forgotten if it's 10 milliseconds. I'm going to guess 10 milliseconds. I probably should look that up. But what it's going to do is run this function over and over again. So it's going to draw and draw and draw. One thing we're going to want to do is clear the document so that we erase whatever was drawn before. Let's create a function to clear. Function clear. So ctx.clearRect 0, 0, and then we want to clear from the top left to the bottom right. So I'm going to put width and height, and we need to create variables for width and height. So let's see, our width is 1200, our height is 800. So let's set these width equals 1200, height equals 800. And we need to clear this at some point in our draw function, so let's start off by clearing everything. So clear. Check that that works okay. Alright, so if it didn't work, it would have crashed before it drew this rectangle. But since it's going down and drawing this rectangle, it must be working. Alright, so we're able to draw rectangles. Now what I want to do is draw an entire grid of rectangles, and we're going to create a grid here to draw mazes on. Let's see. So I'm going to call them tiles, I think. So we're going to have a tile. The width of the tile is going to be 20 pixels, and the height of the tile is going to be 20 pixels. So we're going to create 20 by 20 tiles, and we're going to have 25 rows. So tile, let's call it row count equals 25, and tile column count will equal 40. So we're going to have 40 columns. And then we want to create a double array of tiles. So they're going to have x, y coordinates. So we're going to create a variable tiles, which will be an array. And then for the columns, so from c equals 0, c is less than tile count, column count, c++, we're going to set tiles at c equal to a new array. So we have an array of arrays, which gives us a two-dimensional array. For r equals 0, r is less than tile row count, r++, tiles at cr equals, so we're going to create this with an x coordinate, a y coordinate, and I'm also going to have a state. So that's all the information about the tile. Okay, so the x coordinate is going to be where we're going to draw this along the x-axis, and each tile is going to be shifted over by the tile width plus a little bit of a buffer. So what I'm going to do is actually do c times the tile width, but then plus 3. And so that will add 3 pixels in between the tiles, at least going across. And then I also want that going down, so we're going to set a y value, oops, I forgot a comma, of r plus tile height plus 3, and oops, that's r times tile height plus 3. And the state right now, we'll initialize them all to an e, which means empty. So maybe I'll leave a comment to that effect. So state is e for empty. Except for there's going to be 2 that are special, so we're going to go ahead and begin with a starting tile and an ending tile. So tile at 0, 0. As soon as I get finished creating all the tiles, I'm going to edit this one. So the state is going to actually be s. So I'd like that tile to be my start. And then the last one on the bottom right, so at tile column count -1 and tile row count -1, we're going to make a state f for the finish. So we have the start and finish. So eventually we're going to try to program a pathfinder that can find its way from the start tile to the finish tile without going through a maze that we create. So we're going to create mazes on the fly. Okay, let's go into our draw program. And for now, we'll leave that for the time being. All right, I call it a program, the draw function. So this is a function that we're calling. Let's see, so we want to run through all of the tiles. So for c equals 0, c is less than tile column count, c++, and then for r equals 0, r is less than tile row count, r++. So we're going to loop through all the tiles once again. I guess you can see here I'm assuming you have some familiarity with arrays. I'm not going to explain them from scratch. In the future, if anybody is actually interested in that, I could explain arrays. Okay, and what we want to do is we want to draw something, and it's going to depend on the tile. So we're going to take tile at CR, and we're going to draw it at the x coordinate where we put this tile, and then we're going to take tile at CR and take the y coordinate, and then we're going to make this as wide as the tile, so the tile width, and as tall as the tile, so the tile height. Okay, and I believe that's to draw a bunch of red tiles, which isn't exactly what we want, but at least it's something we can look at, so. No. What did I miss here? I made a few mistakes. So first of all, this should be .state. So I'm setting the state of the very last tile to F. And secondly, I named my double array tiles with an S. So I guess I should put an S everywhere, or of course this thing is not going to run. So those two should have had an S. Tiles at 0, 0 is the start, and tiles, and the last one is the finish. And also down here, in my draw, I put tile instead of tiles, so this should be the tiles X and the tiles Y. Okay, save that. And oops, let's open this up again, and there you go. We have an array of red squares. So the color of the square should depend on the state. So let's also send into this rect function, because all we're drawing is rectangles of tiles. Let's send in the state. Okay, so what we're going to want to here is tiles at cr.state is the state of the tile we're currently drawing, and then up here in our function we're going to need to update that as well. So we're going to have state, and that will determine our fill style. So I'm going to take this and move it up here, and in case this comment's helpful for you, I'll leave it visible. And let's see, so dependent on the state, if state equals start, let's make the start green. So the middle two represent green. And I'm going to go ahead and use else if, so that if that's green it can move along. But if that wasn't the start, the finish should be, let's say, red. And for now, we'll just say anything else. Let's make it a gray. So all color makes white. And so solid FF, 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 all color solid would be white. But if we dim the colors, it's going to be darker. So let's maybe make it like, I'm going to do AA. Let's see how that looks. And most of the tiles should be that color. So wait a minute. What did I do? So it looks like I had one extra A typed out. Let's see, try this again. There we go. I think I was ignoring changing the colors because I had an extra A. However, now you see that this one at 0, 0 is green, and the one at the very bottom is red, and all the other tiles are sort of a light gray. We've got a grid, and we want to draw a maze on this grid. So what we need next is the ability to draw something. So what we're going to need to do is be able to interact, let the user interact with the program. Right now it's just doing its own thing. So we're going to add a function, canvas.onMouseDown. And this is going to equal myDown. So what that does is it's going to run a function called myDown whenever you press the mouse down on the canvas. And we need to create this function myDown so that it can run that function. Okay, so let's do that right down here. Function myDownE. So this is something that's built in clearly into JavaScript. And whenever you create this function myDown, you need to pass in a parameter e for the event. So this is the information about the event. And what we want to know is if we click the mouse down on one of the tiles. So what we want is for c equals 0, c is less than tile column count, c++, and for r equals 0, r is less than tile row count, r++. And what we want to do is go through every tile and check whether or not we clicked on that tile. So Actually, I'd like to get the x and y value. We need to offset it from the canvas. It probably won't be offset at all because I put the canvas in the top left corner. But just in case, let's do x equals e dot page x minus canvas dot offset left, and y equals e dot page y minus canvas dot offset top. So that will take the x and y variables and adjust the coordinates so that the top left of the canvas is 0, 0, no matter where the canvas is sitting on the page. Okay, and now we want to check whether or not we clicked on a tile. So we're running through all the tiles, and C going through the columns, R going through the rows. So if C times tile W plus 3, because that's where the tile is going to be drawn at, is less than x, and x is less than C times tile W plus 3 plus tile W, and R times tile H plus 3 is less than y, and R times tile H plus 3, y is less than this plus tile H. Then we've clicked on tile RC. So this is where tile RC is going to be drawn. This is the amount we've shifted it over based on the column, plus the amount we've shifted it over added to the width of the tile. So if the x is between the left and the right hand side of the box, and the y is between the top and bottom, so here's where we draw the top of it, we've shifted it over, plus how much we've shifted it over added to the height. So what do we want to do? That means we've clicked on this tile. Well, of course, what we would like to do is change the state of the tile. So if the tile at CR is empty, we'd like to make it a wall. So let's say that a tile at CR, two mistakes once again. That's not tile, it's tiles, and that's tiles.state. If the state is E, we're going to make the state W. On the other hand, if the state is W, let's make it E. Okay, cool. So that should switch between whether a tile is empty or it has a wall. One problem though, before we go on, is we're not drawing a wall. So let's do that. This should be else if the state is empty. And let's go ahead and say else if the state is a wall, so it's clear what each case is handling. And let's make it blue. Okay, so we're going to have blue walls in our maze. And it took me a while to figure this out. Nobody likes to record their troubleshooting, I suppose. But in the init function, where did that go to? Init. We don't want parentheses here on draw, so return set interval draw 10. That should just be draw without parentheses. Okay, that was giving me all sorts of issues. That was way harder to figure out than it should have been. Function my down E is, actually let me just go ahead and copy the code that I had before. And this is the price you pay for working in a language you're not so familiar with. So we're going to run through all the tiles, and if they're empty we make a wall, if they're a wall we make them empty. Okay, so let's try this. Great, so I can create walls and start making a maze. The next step is, I don't want to have to click and click and click. So I'd like to be able to click once and drag my mouse and create a wall. Alright, so to do that, we want to create a function that we're going to call whenever we're dragging the mouse, and it's only going to work after we call the mouse down function. So we're going to do canvas.onMouseMove to do something whenever we're moving our mouse around, and we're going to set it equal to myMove. And then we're going to run a function whenever we pick our mouse up. So function myUp is going to set canvas.onMouseMove equals null. So what we're doing here is whenever we click the mouse down and then move it around, it's going to run a function. But whenever we let go and the mouse is up, we don't want this function to run as we move our mouse around. So we're only going to create walls when we're holding down the mouse button. So we need to call that onMouseUp equals myUp. And now then let's write that function. So what do we want to do whenever the mouse moves? Essentially we want it to do the same thing as this, right? So we want to change the wall. If it's empty, we want it to go to a wall, and if it's a wall, we want it to go to empty. So let's just copy that. And then we're going to create function myMove e, and let's do the same thing as whenever we click someplace. You'll see that in a minute why this is important to have two functions, myDown and myMove. Okay, so let's try this out. Okay, so it's working, but look at it going crazy, because every time we move the mouse, it's going to start changing whether it's a wall or not. Oh, by the way, I should have mentioned that since this one has a state of S and not E, the start actually won't change. And same thing with the F. So we don't have to worry about these. Only these other squares. So we're going to do a little trick to get this thing to stop linking like crazy. Alright, so what we're going to do is create two variables. Bound x equals 0 and bound y equals 0. And here we're going to say bound x equals c and bound y equals r. So we're going to keep track of the row and column that we just changed. And same here, so bound x equals c, bound y equals r. That's where I clicked, was on tiles r and c. Okay, now up here, we want to change from an empty to a w if this isn't the tile we just clicked on. And in fact, let's go ahead and add that here, just like we did down there. Bound x equals c, bound y equals r, and same thing here. So we're keeping track of the one we just flipped. So if we flip from w to e, then bound x and bound y will keep track of c and r, because that's the tile we flipped from w to e. So if the tile we're clicking on is empty and c does not equal bound x, let's see, I might not need parentheses here. I think these are going to be three conjunctions. So, well, actually, no, we will need an or, won't we? So it's either this one is not x or r does not equal bound y. Okay, let's close off the parentheses. And then we're going to do the same thing down here. Okay, so we're not going to change it if it's the last one we just changed. Alright, so now if I move my mouse around on one tile, it doesn't change until I move off of it. And now I can draw walls without the tiles flashing around. Oops. And I'm getting this funny behavior that I wasn't supposed to have. It's working even without my mouse up. So let's see what's going on. Ah, you can't spell move with a U. Alright, so lots of errors. I think the next one I'm going to do will be in Java, so that it's not so bad, and I'm a little more comfortable with the language. But at least we've created something where you can draw a maze. And maybe since this is an HTML, you could actually go build a website and let somebody interact with it this way. So this is step one. We're able to draw a maze, and we've labeled a start and a finish. Next time we're going to write the program to solve the maze.